Great. Okay, so in this video, we will be looking at what data modeling in Power BI. So let's jump right straight in. Basically, data modeling is the process of organizing and structuring data in a way that leads to efficient data analysis and reporting in Power BI. That's very easy to understand, right? Good. And so during our process of trying to build a data model in Power BI, we will be going through these various steps, yeah? We'll be going through these various steps. And so as we go along, we'll be looking at what each particular step. So let's move on. So we want to what determine our components of the data model. So let's open our what the file we'll be working with, which is our Excel worksheet. Great. So in this file, as we can see, we have a spreadsheet with what data inside. And so we're told to what identify the components. So our first component was what? Entity, second attribute. For the remaining to look at it when we are in Power BI. So what the entity is what? Is the person, idea or object about which data is what collected. And then the attributes is what information collected on the entity. So when we go to our Excel worksheet, we we have the student data being our entity and what student ID straight up to what bus fee being our attributes because we are collecting what data on the students. You get it right? Good. And so now let's move on to the next step. Now we say what we should group our columns into categories and values. So we've already started our data modeling. Now what are what categories? Yeah, we say what categories are columns with what categorical variables, which means that what they are columns where we do not perform mathematical functions on. And values are simply columns that are quantitative or have quantitative, what attributes or values, which means that what we can perform mathematical operations on them. Let's go to our worksheet. In our worksheet, we have what student ID, or in grouping them into categories and values, we can confidently say that what student ID, student first name, student last name, the region, the address, and the postal code can be considered as what? Can be considered as what? Categories. And then the school fees, the feeding fee, and the bus fee can be considered as what? Can be considered as what? As values. And so, as I did over here, you can see that what? I grouped each of them into categories and what values, where category was represented by what C, and values was represented by what V. Now, next step says that what divide them into what facts and dimension table. Divide what? Divide the category and the values into what fact and dimension tables. Now, what are fact tables? A fact table simply contains all values. So, no, don't forget earlier on we said what values are columns of what quantitative what data. Bring all values and the primary keys in a dimension table. You get it? And the dimension table contains what categories. You know what that's categorical variables, right? That's what categorical variables. The dimension table contains categories, and note it must all be unique. Don't forget, dimension tables contain what unique values. So let's go back. As you can see here, what do you realize? You realize that for our fact table, we had all our values, which is the school fee, the feeding fee, and the bus fee in it. Wait, our dimension table. What does basically our dimension table mean? Good. In creating a dimension table, we only look at the categories. And in the categories, we are supposed to pick subheadings or sub ideas from these categories. So when we look at all these columns having categories, we can commonly say that what we can group student ID, student first name, and student last name under students, which is what we did here. And we can group the region, the address, and the postal code under location because all falls under that same branch. And after we are done, creating this dimension tables, because we are supposed to pick a primary key. Don't forget. Those would pick a primary key, right? And we say that what primary key is what's a unique identifier in a table, which means they're only unique values. And if it's a unique identifier, it means that what when we have our primary key, we can identify other values inside our table. And then good, we have foreign key. So what's the primary key in another table? And so basically our primary key in this table was student ID. Why did I choose student ID? Simple. If you pick these three columns and you go to an institution and you say you are looking for James, we can have about hundreds of people called James, right? But when you pick the student ID and you say you want students with ID number 101, it would give us the student James Miller. I believe that is easy to comprehend. Great. Same as the location. If you pick the region, you can have what the address, the postal code, all embedded inside the particular region. Hence why those were my primary keys. And we are supposed to what add these keys to this what fact table. So now this student ID and region becomes what our foreign key. I believe you get it. That's basically it. I say what foreign keys are primary keys in another table. Simple. And so what's the next step now? As we are done with this, say what all values go into our fact table, which we've already done. All primary keys in each dimension table is added to the fact table. We've done that already. Now we move on to what the creation of our data models. We have two type of designs. We have the star design and we have the snowflake. We have the snowflake schema. Let's start with the star schema. Star schema is basically what? It's a design type in which what? The fact table is surrounded by what? Dimension tables. It doesn't matter whether you have one dimension table outside of a fact table, it is still identified as a what? As a star schema. But for the snowflake schema, it's basically a star schema, but for this very one, we have the dimension tables are connected to what other dimension tables. So when you look at the design here, this is our fact table here, and have our fact tables connected to what dimension tables here. But we can see that what the dimension tables themselves are connected to what other dimension tables. I believe you get it. Great. And so we now move on to what the designing of our data model in Power BI. So let's open our Power BI desktop. Power BI desktop. Let's launch it. Mhm. Great. So now our Power BI is finally open on our desktop. And so what do we do? And in case you want to know how to or you want to know how to get Power BI onto your PC, I have a video inside my channel. You can just look it up in my channel and then know how to download or install Power BI onto your desktop. So let's get our data. Now getting our data, I choose to click folder. Now I'll explain to you why I'm choosing folder and not Excel workbook. Subsequently, as we go on, I will explain to you why, because of certain reasons. But as we go on, I'll explain to you why I'm choosing folder in the first place. So click on what folder and click on what connect. Great. And what do? We need to what place the path of our folder into this what to this very what um how do you call it, into this very box. So click on browse, click on this PC. So I'm basically locating my folder. Yours might be in a different location, but I located mine. Yes, then I click on OK. Now clicking on OK, what do I do? It opens up this pop-up, and I can just choose transform data. But the reason why, but I'm going to choose combine and transform. Now I'm choosing combine and transform because later when later when I want to add new values into this data, I don't have to edit my data in Power BI because it will automatically do it for me. So say there's a new student and I want to input his or her details into this particular table. When I input it here, it will automatically reflect in what's in my Power BI. I believe you understand. Good. So click on combine and transform. Great. We're going to open it for us. Great. So now we choose the sheet which contains or the Excel sheet here for sheet one. Then we click what? OK. Now we click on what? OK. Good. So now open our Power Query editor. In case yours didn't show up, they didn't automatically open. You just come here and what? Click on the Power Query editor what um page so it opens. Great. And so we can see that what our table doesn't really look good and we cannot perform our data modeling with such data. So we need to what clean the data, for it to be prepared. Yes, great. So in our original data, we didn't have this source.name column. So we remove it. How do you do that? Right click the column head and then click on remove. Great. So now we've removed that particular column. And you can also see some null values inside our data, right? We need to remove that also. How do we do that? We come to our home tab, click on what? Remove columns, or we click on the drop down. I'm sorry, we click on remove what? Rows. I beg your pardon. Click on remove rows. And in removing rows, what do? We click on remove bottom rows. Great. Now in this box, it tells us how many rows we want to remove from the bottom up. So we have what? We want to remove 13, 12, 11, and 10. That amounts to 4 rows. We enter 4 and then click on OK. Great. Now see that was our data is almost ready, eh? Great. Now, come in. Great. Now you realize that what? Our student ID, it has a what? A number data type. But you see, initially I told you that what? We are not going to be performing any mathematical operations on the student data because it is what? It is a what? Categorical variable. So let's change the data type to a text data type. Great. And now we are ready to build out our fact and dimension tables. So let's duplicate this particular table. Right click student data, click on duplicate, and rename it into what? One of our dimension tables, which is what student, student, enter. We do the same thing without of what? Location, location, location. As a Nigerian will say, location. Great. And so yeah, we have our what? Dimension and our what? Our fact table, yeah. Now what columns are supposed to be in our what? Our dimension tables. So let's check the original data. Say that what? For the students, it's supposed to contain student ID, student first name, and student last name. For the location, it must contain region, address, and what? Postal code. So all we do is what? Remove the columns that are not or shouldn't be in what? Either student or location, yeah? So let's start with student first. How do we remove column that are not supposed to be here? We come to the home tab, click on choose columns. Choose columns. We uncheck what? Select all what columns. Then we select the columns that are supposed to be in a student table. I hope you all understand. Yes. So we check one, two, three. Then click on what? Okay, great. Now we have that inside our what? Our student table. We do the same for location also. So location, then we do the same thing. Choose columns, then and check select all. We pick what? Region, address, postal code. Great. Select OK. Great. Now we are done with what? Our dimension table. But are we really done? Don't forget, our dimension tables are supposed to contain what? Unique values. Don't forget. So how do we check whether each column is unique? When you hover over this, in case you don't have this, what do? Just come to the view and then check the box for column distribution. Yeah, check the box for column distribution and called column profile. So great. Column distribution. You see that's gone. So when you check the box for column distribution, you have it over there. Yeah, great. And so let's go back. So in order to check whether they are not duplicates, in other words, making every column unique, check whether the number of distinct is equal to the number of unique. If they are the same, then it means that what? Your table is what? Unique, or the column is unique. So when you scroll through, you can see that what? They are all what? Unique values. Then let's check for that of location. So location, we can see that what? There are some duplicates inside the what? The region, because we have 6 distinct and 4 unique. How do we remove the duplicates? You right click on a region and then we scroll down and click what? Remove duplicates. Now great. You can see that what? Our table now is what? Only contains unique variables. Yeah? Fantastic. And so now let's create our fact table. So with our fact table, we can just do it here by like renaming this. Say fact table. Fact table. Yeah? Fact table. Great. And then we leave only the column that's supposed to be in our fact table. What columns are supposed to be in? We have what? These columns. Which is what? School fees, feeding fee, bus fee, student ID and region. Those are the only columns supposed to be in our what? Our fact table. So let's go back. So same, method. Choose columns. We are check the select all. We look on student ID, the region, school fees, feeding fee, and what? Bus fee. Click on what? Okay. Fantastic. So our fact table is ready. So basically now we have everything prepared in order to build out our data model. So since everything is checked, we click on what? Close and apply. Now when you close and apply, what happens? is going to load into our what? Our Power BI desktop. As you can see, it's loading. Let's wait patiently for it to finish loading. Great. So let's now check out model view. So now in our model view, as you can see, we've created our data model, yeah? Now I know you're all wondering, how come I have it has automatically connected? Well, Power BI has been able to automatically identify this, and it's not by magic. You need to enable this feature. How do you enable it? You go to your file section, click on what? Options and settings. Click on options. Then go to what? The data load. Then under relationships, you check the what? The auto detect new relationship what box. You get it right? Good. Now let's click on OK. Great. We can see that what it has automatically what connected our data. Now this is what we call cardinality. You realize that when we hover around our link, it tells us what the primary key, or it tells us what or in which way the dimension table is linked to the fact table. As you can see, we placed our region or a foreign key or the region column into what a fact table. So what if this is the primary key, this is the what the foreign key, yeah? Same thing to this. Now say you don't have the what the you don't have this connection to your from the fact table to the dimension table. So you let me delete this first. Great. How do you create a connection? So you just pick the primary key here, which is your student ID. You double click it or you drag it and you drop it inside what? The foreign key here. Then what do you realize? It creates the what? It creates a relationship. You get it? Great. So that's basically it. In case maybe you didn't have a relationship inside, that's exactly how you do it. Great. So now we are done with our what? Our data model, and I believe we all know exactly what type of data model is this. You say what? Or what type of data design it was. But we can confidently say that what? Oh, okay, let's just look at it. So you say a star schema is one in which was the fact table is surrounded by the what? By dimension tables, yeah? And snowflake is what? One in which what? The dimension tables are connected to what other dimension tables. And so when we look at this particular model, what type of design scheme is it? So basically it's a what? It's a star what? It's a star schema. That's basically what it is. And so we have come to the end of our video. I want you to like and subscribe, and then I'll see you in the next video. Adios.